For generations, one destination has captured the imagination of astronomers more than almost any other place beyond our solar system. It isn't a distant galaxy billions of light-years away or an exotic black hole hidden in deep space. Instead, it's our closest neighboring star system, Alpha Centauri. Only a little more than 4 light-years from Earth, Alpha Centauri has always seemed like the most logical place to begin the search for other worlds. If planets exist around nearby stars, this should be one of the easiest systems to investigate. Yet, despite decades of observations, Alpha Centauri has remained surprisingly mysterious. Scientists have searched this system using nearly every modern technique available. Powerful telescopes scanned its bright stars. Sensitive instruments measured tiny gravitational movements. Researchers analyzed years of astronomical data hoping to uncover even the slightest hint of an orbiting planet. But every promising clue seemed to fade before it could become a confirmed discovery. The biggest challenge isn't distance. Ironically, it's brightness. Alpha Centauri A and Alpha Centauri B shine so intensely that any nearby planet is almost completely hidden within their overwhelming glare. Imagine trying to photograph a tiny firefly while standing directly in front of a giant spotlight. Even the most advanced telescopes struggle with that kind of contrast. This is where the James Webb Space Telescope entered the picture. Unlike previous observatories, Webb was designed to study the universe in infrared light with extraordinary sensitivity. Its advanced instruments allow scientists to search for faint objects that would otherwise remain invisible beside brilliant stars. When astronomers pointed Webb toward Alpha Centauri, they weren't expecting an easy discovery. They knew this would be one of the telescope's most difficult targets. Then something unusual appeared. During one observing session, researchers detected a faint source of light near Alpha Centauri A. It wasn't bright, but it stood out enough to attract immediate attention. The object appeared to be located at a distance where a large planet could potentially orbit its parent star. Naturally, excitement spread through the scientific community. Could this finally be the first direct evidence of a planet orbiting our nearest sun-like neighbor? If confirmed, the discovery would represent a major milestone in astronomy. Finding a nearby exoplanet would provide future telescopes with an incredible opportunity to study another planetary system in unprecedented detail. But science demands evidence, not excitement. Astronomers returned for additional observations, expecting to see the mysterious object once again. Instead, it was gone. No obvious planet. No repeated signal. No clear confirmation. At first glance, the simplest explanation was that the original detection had been caused by background interference, an instrumental effect, or another astronomical object unrelated to Alpha Centauri itself. Many discoveries in astronomy begin with false alarms. That's part of the scientific process. However, the story didn't end there. Researchers noticed that although the object couldn't be confirmed, they also couldn't completely eliminate the possibility that it had been real. Planets don't remain fixed in the sky. They orbit their stars continuously. Depending on their position, a planet can sometimes disappear behind the overwhelming light of its host star or move into an angle where current instruments can no longer detect it. In other words, a planet might still exist, even if we can't currently see it. That possibility transformed what initially looked like a disappointing result into one of the most intriguing mysteries surrounding our closest stellar neighbor. The question was no longer whether astronomers had made a mistake. The real question became, what if something is genuinely hiding within the Alpha Centauri system, waiting for the right moment to reveal itself? If a hidden world truly exists within the Alpha Centauri system, it could completely reshape our understanding of the nearest stars to Earth. But discovering such a planet is only the beginning. The real mystery lies in understanding what kind of world it might be. Unlike our solar system, Alpha Centauri is a binary star system. Two Sun-like stars orbit one another over thousands of years, creating a constantly changing gravitational environment. Any planet living in this system must survive the influence of not just one star, but two. That makes planetary orbits far more complicated. Instead of following nearly circular paths like Earth, some planets could travel along stretched or tilted orbits. Others might remain hidden behind their parent star for long periods before briefly becoming visible again. From Earth's perspective, timing becomes everything. This is why astronomers rarely rely on a single observation. Every possible discovery must be tested repeatedly over months or even years. A planet that disappears isn't automatically ruled out. It may simply have moved into a position where current technology can no longer detect it. That possibility keeps Alpha Centauri at the center of scientific interest. If the faint signal observed by researchers eventually proves to be a giant planet, the discovery would still be remarkable. Large planets often possess extensive systems of natural satellites. In our own solar system, Jupiter and Saturn are surrounded by dozens of moons, several of which have become major targets in the search for environments capable of supporting life. Scientists have learned that some icy moons hide enormous oceans beneath their frozen surfaces. These underground seas may contain many of the ingredients considered essential for complex chemistry. While this doesn't confirm life exists elsewhere, it demonstrates that potentially interesting environments are not limited to Earth-like planets alone. The same idea could apply to Alpha Centauri. Even if the first confirmed world turns out to be a massive gas giant, its moons, if they exist, could become equally fascinating objects for future exploration. Another reason Alpha Centauri receives so much attention is its incredible proximity. Compared with the enormous scale of our galaxy, 4 light-years is practically next door. For decades, engineers and scientists have considered this system the most realistic destination for humanity's first true interstellar mission. Future generations of spacecraft, using technologies far beyond today's capabilities, may eventually travel toward these neighboring stars. Before that journey ever begins, astronomers hope to answer one critical question. What exactly is waiting there? The James Webb Space Telescope has already expanded humanity's understanding of distant galaxies, ancient stars, and alien atmospheres. Yet one of its most intriguing investigations involves a destination that has been visible in our skies for centuries. Rather than delivering a final answer, Webb has revealed just how much remains unknown. Every new observation adds another piece to an unfinished puzzle. Some mysteries disappear with better data. Others become even more interesting as new evidence raises fresh questions. Alpha Centauri belongs to that second category. Whether the mysterious signal was an undiscovered planet, a temporary astronomical effect, or something entirely unexpected, it reminds us that the closest places in the universe can still hold the greatest surprises. As future observatories become even more powerful, astronomers will continue searching this nearby stellar neighborhood with greater precision than ever before. The next observation could reveal a hidden giant planet, a family of distant worlds, or something nobody has yet imagined. Until then, Alpha Centauri remains a symbol of exploration, a reminder that even our nearest cosmic neighbor still guards secrets waiting to be uncovered. The universe rarely gives away its mysteries all at once. Sometimes, it reveals them one faint signal at a time.